Hello, everyone. In this lesson, I wish to talk about some other cases that involve limits and how do we make the case to demonstrate that the limit does not exist or the limit is infinity, especially in this section that we cover limit at infinity. Okay, I pick up 4 examples here that how do we make the case? Because we know that when we have a limit situation, okay, when we have a limit situation and we have talked about, right, whether x is approaching a, if f is approaching, if we limit f of x plus or minus g of x, right? When both limit does not exist, we cannot apply limit law. Okay, we cannot apply limit law, so we can only apply limit law if both limits individually exist. Okay, so on limit law, we have this very important assumption that it has to both limit individually must exist, and then we can do adding, subtracting, multiplying, dividing, and also guarantee the denominator of the limit does not equal to 0. Okay, and also and other properties on the next slide. And also we understand when we encounter a situation, right? One function approaches infinity, another function approaches infinity, right? So, for example, okay, we saw a lot of cases, right? We have a limit, right? We have a limit, one approaches infinity, right? So this one approaches infinity, right? It could be x approaching a or x approaching infinity, and both approaches infinity. V approaches infinity. Okay, it could be plus minus infinity. It could be plus minus infinity, and we cannot say, okay, we cannot say, right, the sum of differences will be approaching infinity or 0. And in truth, we have seen many, many examples. For example, in this case, in this example, right, we have talked about techniques that in cases like this, right, we have x as x approaching infinity, the root of x squared plus 1 approaches infinity minus x also approaches infinity. So we have infinity minus infinity case. Does infinity minus infinity equals to 0 or it equals infinity? So in these cases, it's uncertain. It's uncertain. So we cannot make that case say infinity subtract infinity is going to be 0. Okay, in truth, we have seen many examples that infinity minus infinity could be any number you want. Okay, and we went through some examples in the previous videos. Okay, we're going to cover this question and this 12 and 13 in this lesson. Okay. But we covered examples that we have infinity, like in this case, the first one, right? The first one, we have this page. I'm sorry, this page is looking a little weird. Okay. Right? You see, in number 6 case, when x approaching negative infinity, the numerator approaches negative infinity, denominator approaches negative infinity, and we will be able to find the limit. We know the techniques, how to do it. So we have gone over those examples in the previous videos, in previous lessons. However, However, in case like number 19, right? And in cases of like this one, right? Number 13, number 12, how do we make the case? How do we make a case that it looks like it's going to be approaching infinity, but how do we make the case? We certainly cannot use the argument that infinity minus infinity is infinity, because we cannot apply limit law. Infinity minus infinity is not necessarily infinity. So in this lesson, I'm going to show you how do we make the case that there's certain techniques, okay? There's some algebraic techniques we can use to make our case. Okay, so that was the introduction. So how do we make the case on a limit when it is infinity or positive infinity, negative infinity? Take the first one, for example, okay? Take this from is number 12, number 13 are similar. Okay, so on this one, on this case, we certainly cannot, right? So let's make a note. We cannot apply limit law. We cannot do the following. We cannot do this. Okay? We cannot apply limit law because limit law does not apply. Limit law only applies when each individual limit exists, which means a finite number, and we don't have that. We cannot do this. And what can we do? What can we do? Okay, we also cannot argue that infinity minus infinity is infinity, it is zero. And we cannot argue that infinity minus infinity is going to be infinity, okay? Because it's uncertain, right? We have lots of cases. So what will be the argument we can use to make our case? So this is what we can do. We certainly cannot apply limit law, but we can factor. Okay, so we're going to factor. Okay, hold on. I'm going to make it just a little bit tighter. Okay, we're going to factor this, and we get x times x minus 1. Excuse me. So now, as x approaching infinity, of course, x approaches infinity, x minus 1 also approaches infinity. So we have an infinity, something approaches infinity, multiply another quantity also approaches infinity. So now we can say it is approaching infinity. So the fact we use here is the product of infinity is infinity. Okay, the product of infinity with infinity is infinity. Okay, everybody has to agree with that, right? If you have one quantity that is infinite, that approaches infinity, another quantity also approaches infinity, and they're in multiplication, of course, the product is going to be approaching infinity. So this is the argument we can use. We cannot use the other arguments, okay? So by the same analysis, we can work on the next one. The next one is a case that when x approaching infinity, the numerator approaches infinity, the denominator approaches infinity. So guess what we cannot do? We certainly cannot do, right? we cannot apply limit law for sure. Okay, so we cannot apply limit law. And also, we cannot use the argument saying, oh, infinity over infinity is equals to 1. And we also cannot use the arguments that saying, oh, infinity over infinity is infinity. We have seen many cases, right? Infinity over infinity is going to be a constant, or sometimes is 0, like in number 5's case. And we have many examples previously. So we cannot use these arguments. So what arguments can we use? Okay, so here it is. So once again, we're going to use product. And how do we do that? How do we do that? Okay, we're going to factor. We're going to factor. The top will be factored into x times x plus 1. Okay, so we can put this x over here in the front of it. Okay, we cannot separate them. We cannot separate them, but this quotient, right, as x approaching infinity, by the way, we cannot use the limit law, but we understand, right, this limit as x approaching infinity is going to be -1. You know the techniques to do it, right? You know the techniques to do it. We just, divide the top by x, divide every numerator by x, divide every denominator by x, right? So this is the technique we used all along. So after this technique applied to it, and we will get 1. This is a -1. For this piece, we can apply limit law. After we apply limit law, okay, so let me just show you one more step to apply the limit law. So this is just to say, one of the quantities has a limit in our product, in the quotient, right? This piece has a limit, but this piece does not. Therefore, we cannot use the limit law because one of it approaches a constant, which is -1, right? And in operation, you can see I did not do this along this, within this. I did it separately. I'm just explaining to the reader that as x approaches infinity, this quantity approaches a constant. And x approaches infinity, and this constant is -1. Therefore, this entire quotient is going to approach negative infinity. So this is how you show work. Okay, this piece is, whoops. Oh, this mouse is a bit, okay. So this piece is how you show work and explaining why this piece is a constant. These work need to be shown separately, okay? You cannot embed this part inside here because you cannot apply limit law. All right, so never ever apply limit law here, but we're just saying this quantity approaches a constant -1 and the other quantity approaches infinity and the whole thing approaches negative infinity. I hope you get that. Okay, so this is the technique we use, which is either infinity multiply, infinity is infinity. or infinity multiply a constant is infinity. Okay, so the same technique can be used for these other two. Okay, these are from your homework questions, right? The only difference here is that this is power 2, this is power 1. And we know the top approaches infinity, the bottom approaches infinity, the arguments are the same. We cannot apply limit law. And we also cannot argue that infinity over infinity is going to be infinity or 1 or 0. So we apply the same technique. Okay, so once again, we're going to do factoring. So factoring out the x, right? So this is a 1, and this is 3 times x. And this whole piece, this piece approaches a constant. We know it's 3/4. And so as x approaches infinity, this portion approaches a constant, and x approaches infinity, so the whole thing is going to be approaching infinity. So it's the same technique, and we can apply the same technique for the next one. So once you understand how it works, right, the control work part is just, you can just write it this way. You can just write it this way. And then for this one, and you also write x times, right? So this is going to be x raised to the power 3 after x being factored out, and this is going to be just x, and this is just 1. Okay, and this piece approaches a constant, which is 1, and as x approaches infinity, so this thing is infinity multiply a constant, so the limit is going to be infinity. Okay, so this will make it, I hope, make it complete about all the questions as far as how do we handle these questions, whether the limit exists or limit does not exist, and how to make our cases, All right, if you have any questions, please don't hesitate to reach out to me. Thank you for watching.